Now we go into the understanding of module 4, and the contents of module 4 are as follows. So here we will look into sequential circuit design and dynamic logic circuits. In the earlier topic, that is module 3, we had a discussion on combinational circuit design. Right now we are considering the sequential circuit design, which is based on one input following the one input giving us the output, and that output is fed as input to the next circuit. So the basic topics involved in sequential circuit design is it requires memory, and the circuit design, it is the important concept used here are the latches and the flip-flops. And next you have dynamic logic circuits. So this is almost the same as your CMOS, but then extended version of CMOS here with the influence of the capacitor being introduced here. So that is what we will be discussing here in the next topic. Right now our focus would be on sequential circuit design, which is introduction circuit design for latches and flip-flops. Look into this topic called as pulse latches. So what exactly is pulse latch and how the construction is based on? It can be built from a conventional CMOS transparent latch driven by a brief clock pulse. So almost you have the conventional CMOS latch which is driven by a clock pulse. So figure shows the simple pulse generator, which can also be called as a clock chopper or one shot. This is regular this is faster than the regular flip-flop because it has a single latch only. Earlier there were two latches, but here since there is only one latch, it is faster than the flip-flop. And therefore, apart from that, this also consumes lesser energy, although the pulse generator adds to the energy consumption. Though it consumes less energy, this pulse generator itself is responsible for energy consumption. Not all the while it is advantageous, it has good signs. There is also a drawback in this. What is the drawback here is it has an increased hold time. It has increased hold time. This pulse generator uses a slow or a weak inverter here to produce a pulse, in weak or a slow inverter to produce a pulse with a nominal width of about 1/6 of the cycle. So this is responsible for generating a nominal pulse. When disabled, when this inverter is disabled, the internal node of the pulse generator floats high, but there is no keeper which will keep the duration short. No keeper is required because the duration is short. Of course, the enable signal has setup and hold requirements around the rising edge of the clock as shown in figure C. So this is your clock pulse 5, and this is the enable signal which has been given here. So it is shown here when the clock is high, the enable is low, and it is as per the generation it goes on. Next you have 5P, which is the output. So if you check in the output, 5P is given as only one interval, that is where it starts 5 in the second half, where it starts, and in between it ends with respect to the enable. So this is the significance of the pulse generator. Next we have another pulse generator. Alright, okay, the same generator which is meant for another application. So here this is a pulse generator which is used to produce substantially longer pulses. So earlier in our diagram we saw the pulse was very short. Now if you want to have a bigger or a longer width, then it is possible to call or longer pulse. So this is possible by including a built-in dynamic transmission gate latch. So you have seen a built-in transmission gate latch, which is meant to prevent the enable from glitching during the pulse. If there are any problems in the form of voltage swing, that can be avoided by having the transmission gate. So the pulse generator should be carefully simulated across process corners and possible RC loads to ensure the pulse is not degraded too badly by process variation or routing. So this pulse generator should be simulated such that RC loads also should be properly ensured and taken care to see that that will not have a drastic effect, or in other words it will not degrade, and as a result it will not degrade by the process variation or by routing. So the pulse generator should be simulated. In case of proper or wrong routing algorithms, they can give rise to a degraded version. Pulses could be used as regular clocks as long as the pulse generator has adequate drive. So pulses, this can be used as a regular clock until the pulse generator has adequate driving capability, So wider pulse offers more robust latch operation across process and environmental variability and permits more time borrowing but increases the hold time. There is a drawback. So right now what we are trying to do is we are trying to generate a longer pulse. Longer pulse means the width has to be considered. So when you consider the width, it has very good latch operation. It has very excellent behavior with the environment variability, but it is also having more of the hold time. So this is one of the catch or the drawback of pulse generator, and we can fix it with something called as multiplexer. So what is the purpose of multiplexer? Multiplexer select is a software programmable to fix problems discovered after fabrication. You have something called as multiplexer select. So this is meant, it is a software which is meant to fix the problems in case if any problems are there after fabrications. So after fabrication, if you find some flaws, you have no possibility of rectification. Only thing is you have to dump it and redesign and use a fresh one. So in that case we have some tool or like software which is called as multiplexer select, with the help of which we can rectify the problems in the transistor even after fabrication. Next we have something called as the Pertovy pulse latch. So this is the Pertovy pulse latch, which is meant to eliminate the need to distribute the pulse by building the pulse generator into the latch itself. So it eliminates the need to distribute the pulse. The pulse is being distributed by building pulse generator. Next we have weak cross-coupled inverters in the dashed box. So we have a cross-coupled inverter, one inverter acting as the output to the next stage, and it is weak. Notice the size of this transistor. So one is strong and the other one is small. So it is called as weak cross-coupled inverters, and this is inside the dashed box. And the purpose of this is to satisfy the circuit, because it is dynamic, it is prone for fluctuations, therefore it has to have a stability, and that is called as staticize. Although the latch is susceptible to be back driven output noise on Q or Q unless an extra inverter is used to buffer the output. So the latch can be back driven on Q, that is Q is your output or Q bar, until and unless you have an extra inverter which acts as a buffer for storing the output. So we need to have a respective storage device in order to uh, buffer the output. The part-OV pulse latch is slightly slower than the simple latch. So of course there are so many features, extended features, but still it is considerably slightly slower than the part-OV than the simple latch. Therefore earlier this was called as edged trigger latch, ETL. But strictly speaking it is a pulse latch because it has a brief window of transparency. So Patrovi latch is meant for all these applications. It has a better way